Okay, so in this video we're going to be talking about the properties of logarithms. So we're going to be expanding them and we're also going to be condensing them. So here are my properties. If I have them being multiplied, to expand it, multiplication also means we can separate it using addition. When I'm dividing, to expand it, we use the same logs again, but this time it represents subtraction. My last rule is if I have an exponent, we can move that exponent to the front. Or the opposite direction. If I have something in the front, it can also be an exponent. Okay, so we're going to condense these, so we're going to make them smaller. We're going to get them to have one log. So minus sign means to divide. So when I rewrite this, I got log of the same base of 32 divided by 2. 32 divided by 2 gets me 16. And this is something that we've seen last time. So if I set it equal to x, I do base to my power. Base power what it's going to equal. So 4 to the x is equal to 16. So what when I type it in for x, right there gets me 16? Well, 2 does. So you are rewriting it with the property and then seeing if you can simplify if it's all numbers. So my next one, okay, if I have a number in front, I need to send it back first before I do any multiplying, adding, or dividing. So I now have log base 2 of x to the 6 plus, got to send this one back, log base 2 of y to the 5th. Now I work with this plus sign, which also means multiply when we're trying to condense. So x to the 6th times y to the 5th. Okay, my next one, it doesn't have any exponents or numbers in the front to send back to make exponents, so I work with this plus sign. Plus sign means to multiply when I'm condensing. So I keep the same base. I now have 5x times 3x. Keep the same base. 5x times 3x gets me 15x squared. Okay, my next one, we need to send the 2 back, so I got log base 4 of 6 squared minus log base 4 of 9. Minus sign means we are dividing. So I have 6 squared now divided by 9. If it's all numbers, we need to see if we can simplify. So log base 4, 6 squared is 36 divided by 9, which is then 4. I type this in. Remember, we could do it with a little equal to x. So my base, my power, what it's equal to. So base power, what it's equal to. What number, when I plug it in for x, will get me it to equal 4? Well, 1 does. Okay, my next one, we're going to expand it, so we're going to make it bigger with a bunch of logs. So we work with this division sign. That means to subtract. So I'm going to subtract that y. Now this 4 and this x need to be separated. So we're trying to separate everything. So since it's being multiplied, we now need to add it to that x. And then we keep the same log bases. Okay, and next one, looks like we got another division sign. Okay, so I got log base 9 of x to the 4th minus, division means minus, log base 9 of 729. I have to bring this 4 to the front. So last time we were doing it, whenever you had a number in front, you sent it back first. Now it should be your last step. So now I got 4 log of 9x, log base 9 of x, and then I check to see if this can simplify. So I'm going to write them over on the right side. So log base 9 of 729, I set it equal to my x. So I go base exponent what it's equal to, so base exponent what it's equal to. So what number, if I plug it in for that x, could get me 729? Well, 3 does. So now I can replace him and put a 3 in there. So that is my final answer. Okay, it looks like we got another subtracting. So log base 3 of 250 minus log base 3 of 37, and then we got to check both of them to see if we can simplify since they're all numbers. So I got log base 3 of 250 equal x, so I go base power what it's equal to, base power what it's equal to. So if there's anything that I can type it in for that x to get me 250, there's not, so he's just going to stay like that. My other one is 3 and 37. Oops. 37. Set it equal to x. I go base power what it's equal to, so 3 to the x is equal to 37. There's nothing when I plug it in for x that's going to get me to that either, so we're just going to leave him like this. Okay, my next one. It looks like we got some multiplication happening in here. Remember, the exponent is what we deal with last. So I got log base 3 of 9. Multiplication means addition. Log base 3 of x to the 5th. Now I can bring my 5 forward. So log base 3 of 9 plus 5 log base 3 of x. My first set here is all numbers, so I'm going to see if I can simplify. So log base 3 of 9, I set it equal to x. I go base power what it's equal to, so base power what it's equal to. Well, I can plug 2 in to get that to be simplified. So here is my simplified version this time. Okay. This one, we're still expanding. Okay, so there's two different ways to do it. We could bring our exponent to the front first, in which case I'd have 2 log of 3, and then my 2x, in which case I would split this using a plus sign. So I'd have 2 log of 3, 2, plus 2 log of 3x, in which case the 2 would stay with it. The other way to do it, if you're not sending the 2 up first, is distribute the power in to simplify. Power to a power we multiply, so this would become log base 3 of 2 squared and x squared, because 2 times 1 gets me 2. And then you would separate it to get log base 3 of 2 squared plus log base 3 of x squared, and then you'd bring the 2's up. When you bring the 2's up, you get the exact same answer. So there's two different ways you could do this one. Okay, my next one, if you remember, square root has a little 2 out here. All of this is to the first power. So if I wanted to rewrite this, this is 2xy to the 1/2. Okay, square root means the same thing in exponential as 1/2. So you can follow suit the exact same way that we have been doing, in which case you could either bring the 1/2 to the front, in which case it's log, 1/2 log of 2x over y, and then we split it. That minus sign, or that division sign, means a minus sign. The 1/2 needs to follow suit with both of them. And now I need to follow this multiplication sign, which is a plus sign. Log of x minus 1/2 log of y. Okay, the other way you could do it is you could distribute that 1/2 in. So I'm going to rewrite them over here. So log of 2x over y to the 1/2. All of them have the exponents of 1, so when I distribute the power in, power to a power, I should multiply. So I got log of 2 to the 1/2, x to the 1/2, y to the 1/2, and then we go into our break again. So the division sign would mean subtraction, and the multiplication sign would mean addition, and then I'd have to bring the 1/2s to be in front of all of it again. So you could do it both ways, but that should be your final answer for it. Okay, the last thing we're going to talk about is the change of base formula. So this is where maybe I have something ugly and I'm going to some ugly numbers here where I can't set it equal and get something pretty. So an example would have been when we did this. Okay, 3x equals 37. This is going to be a decimal here. So this change of base formula changes it to base of 10, so that all we have to do is type in our calculator to get the actual decimal to make it work. So when you do it, when I say big number on top, I mean just big M here goes on top, not literally the bigger number of 81 or 45. Okay, the M goes on top, the B goes on bottom here. The C's represent base 10 so that we can type it into our calculator. So when I do this, my big one goes on top, so I got log base 10 of 27 over log base 10 of 81. If you type this into your calculator, you should get 0.75. Okay, so normally we would set this equal to x. We do base to power, and what it's equal to. So we would have gotten 81 to the x is equal to 27, and then we would have tried to break it down. Or you could do this change of base formula. If you put this back in here, 81 to the 0.75 should equal 27. So this is an easier version of just getting that number straight up very, very quickly. Okay, so my next one, I got log base 10 of 36 is equal to log base 10 of 5. So when I type it in, I type in log of 36. I end my parenthesis divided by log of 5. I press enter. This time I got 2.2266. Okay, so normally we would do equal to x, base power, what it's equal to, so 5 to the x is equal to 36. Okay, that's a really hard one to be able to do, but if we use our change of base and I put this back in, it should get me pretty close to 36, depending on if I rounded this or not.